Hi there, this is Penelope. This is a short video, this time on fractional indices, fractional powers, in a series of short videos on basic arithmetic skills. And the question we've got to ask ourselves here is, how do we interpret an expression such as x to the power of a third, where the power is a fraction? Fractional indices are used to express roots of a number. And to find the root of a number means it's the reverse process to calculating a power. So, for example, if we're working out the fifth root of 1024, what we're working out is the number, what number to the power of 5 gives us 1024. So let's rewrite this in notation. The fifth root of 1024, now that's just a little 5, it's just a wee baby 5, is equal to some number, means that x to the 5 is equal to 1024. Now, we know about these. We know, for example, that the square root of a number is the number which multiplies by itself gives that number. So the square root of y times the square root of y gives y. Now, it must also be true, because we know about this, that y to the half times y to the half is equal to y to the 1, but I don't need the 1, like that. So if both of those are equal to y, then root y must be equal to y to the half. So what we've got now is that the nth root, this was only the square root, but the nth root of something, some number, must be equal to the fractional power. Okay, the left-hand side here is what we call the surd form of this expression, and the right-hand side is the index form. So it gives you an idea of the meaning of a power that's actually a fraction. So here's the first few listed. X to the power of a half is square root, x to the power of a third is the cubed root, x to the power of a quarter is the fourth root. Now let's have a look. 81 to the power of negative a half. That negative a half means it's 1 over 81 to the power of a half. Now the power of a half is square root, so we can say that that's 1 over the square root of 81, which, if we were being really careful, really pedantic, we'd say was plus or minus 9, 1 over 9. We can use our rules to find this one, and that one. Well, that's not quite the same as what we've been looking at. So we need a meaning for these expressions when the numerator is no longer 1. Let's have a look at an example first. X to the power of 2 over 3 means the cube root of x squared. And x to the power of 3 over 2 means the square root of x cubed. So the top number represents the power and the bottom number represents the root. So it's the nth root of a to the power of m, and it doesn't matter whether you find the nth root and then take it to the power of m, or find the power and then take it to the nth root. So square root of x, we already know that one, that's x to the half. The cube root of y is y to the third. Over here a little bit further is the fifth root. It's the square root of x to the power of 5. So it's x to the power of 5 over 2. And the last one is 5 to the power of 7 over 3. So from the previous slide, we can now understand what 5 to the power of 2 over 3 means. It means the cube root of 5 squared, and 5 to the negative 2/3 means 1 over 5 to the 2/3, so it means the reciprocal of the cube root of 5 squared.